Hello and welcome to this webinar on the next generation of hydraulic modelling with InfoWorks WS Pro. My name is Stuart Hall-Cooper. I'm the Head of Global Marketing at InfoWorks. Let's introduce our presenter today, Luca Serena. Luca has a background in hydraulic engineering and wastewater modelling. He's now a technical sales engineer with InfoWorks. As well as working with our wastewater and stormwater products, he is now one of our specialists in water supply, real-time model forecasting and real-time analytics. So wasting no time, Luca, over to you.
Thank you, Stuart, and thank you all you for joining InfoWorks today for this webinar. Today's webinar is about InfoWorks WS Pro, which is the InfoWorks standalone modeling platform for water distribution system. This is going to be pretty much an interactive session. I will stop my presentation 3 times to ask you some polling questions, and you will have the ability to choose between different answers. And that will hopefully give us a feedback on the people attending. We have 350 people registered today for this webinar, so the answer to this question will give us a good feedback on the specific question that we will be asking. So, starting from the very beginning, an hydraulic model is a mathematical representation of a water system, a sewer system, or a storm system, and is generally used to analyze the system hydraulic behavior. Today's webinar is on InfoWorks WS Pro, so we will be simply focused on water supply system. So, an hydraulic model is generally composed by using some GIS data, and we input that data into the model to create a physical representation of the real world system. We could also use some system loading data that we can get from our clients, like flow metering, water consumption record, or we could also use estimate from customer characteristics like population data or land use data. We then apply some modeling parameters like pipe roughness, just to mention an example, and by doing that we have a working model that we can calibrate and we can then use to support our understanding of the behavior of the system. But the question is, what do we use the hydraulic model for? So most of the time, hydraulic models are used to create water master plan, or perhaps if you want to find a method to improve the system reliability and efficiency by evaluating existing or future configuration of the network. The model can then be used really for a wide variety of use, like identify pressure, provide firefighting capability, identify bottleneck, overload pipes, turnover reservoir, or for doing some water quality analysis, identifying water age, or transient analysis to identify pressure surge. So I'm just now going to stop the presentation because I'm going to ask you the first of the 3 questions that I will be asking today, which is actually, what do you use your hydraulic model for? So you can choose between different answers, network planning, operation, water quality, hydrant testing, critical link analysis. Please choose one of them, and because I will stop the question very soon. Okay, so just to share the result, as you can see, 94% of the people use the hydraulic modeling for network planning, but some of them are using for operation or critical link analysis. But there is still a number of people that use the hydraulic model for performing hydrant testing. So I'm now going to switch back to the PowerPoint just to continue the presentation. What is the current situation of hydraulic modeling? Across the UK now we have been using hydraulic models for many years, and we use them to drive all major investment decisions. Based on what we have seen in the industry, models are generally used to enhance knowledge of the system, as I was saying before, to ensure that assets are efficient, network planning, and customer service level are met. But we are now at the point where we have to face some new challenge going forward. The first one is environmental challenges. Climate change and population growth over the next few years will place increasing pressure on our system. There is customer expectation in terms of quality of the service, in terms of information that goes to the client. And finally, resilience of the system and resilience of the service, which means increase our ability to cope with disruption and to maintain service at all times for all the clients. So to address those challenges, OFWAT have identified 3 key themes in PR19. They are actually 4, but I just focused on 3 on this presentation, which will be the main driver for the next AMP cycle. Great customer service means innovation, means reliability, and means responsiveness. Affordable bills means that company will need to deliver a step change in efficiency in order to provide more for customer, but at the same time reducing the bills. And this can only be achieved, for example, by reducing leakages. Long-term resilience is an important discussion, which basically means reduce the probability of water supply interruption. So on one extent, this all mean that we need to make a better use of the resources, of the tools, of the information that are already available. But on the other end, we'll also need to invest in innovative solution and technology. Concerning this second point about innovation, on a separate webinar, Innovize will show how hydraulic modeling relevance can be further enhanced by adopting a real-time modeling strategy. This will basically allow our model to become a valid and reliable support tool to identify network faults in real time, so as soon as they occur. This essentially means responsiveness in case of water supply interruption, pipe burst, and leakages. So in one word, just to make a better use of the water resource. But again, this will be covered on a separate webinar, which will be published on the Innovize website very soon, and you can register from that. So if you're interested, I would recommend you to keep an eye on the Innovize website, on the webinar page, and register as soon as this webinar will be published. Today's webinar is indeed more focused on what we define as offline model. So a model that is not constantly updated or verified against telemetry. We are talking about a model that was built and calibrated in the past, and we generally use for network planning, design, and on a certain extent even for network operation, as we saw before. So we will start from this to show how InfoWorks WS Pro can provide a support tool to meet OFWAT requirement. Just to mention a few things, InfoWorks WS Pro is the replacement of InfoWorks WS, and in InfoWorks WS Pro we adopted the latest computer technology, which allows the step further that I was mentioning before in hydraulic modeling. This because InfoWorks WS Pro is a real workgroup product, and the main enhancement that it allows is that you can have multiple users working on the same time, but at the same time it allows multiple distributed simulation across a pool of dedicated simulation machine, what we call remote agent, that we can use to perform simulation quicker. And it does have network database and result sharing as well. So just to explain a little bit more about this technology implemented in WS Pro, and then I will go back to the OFWAT requirement. InfoWorks WS Pro comes with what we call a coordinator, and the job of the coordinator is basically to control the traffic of data between local agents, which is where the engineer sits and build their model, and the remote agent, which are machines that are designed just to run simulation. So as from the local agent, we can build a model and we can run the simulation on the same machine. But if we have to run what we call composite run, which means multiple simulation at the same time with different control to model different scenarios, we can give the workload of this simulation to the coordinator, which will then split the jobs between all the different remote agents that we have available on our office. The result then can be saved on a shared location so that all users will have access to the result without having to rerun the simulation. So this is also a key point here. Now, going back to OFWAT, to the 3 key themes that I was treating before, we spoke about innovation and we kind of pushed that back to a separate webinar. The second theme is really resilience. And resilience, as defined by OFWAT, is the ability to cope and recover from disruption. And always reading from the PR19, we can see that resilience could be secured by 4 key strategic components, which are resistance, reliability, redundancy, and finally response and recovery. So resistance essentially means preventing damage by providing the strength or the protection to resist. Reliability means ensure that infrastructure components are designed to operate under the specific range of conditions. Redundancy really concerned with the design and the capacity of the network. Response and recovery means enabling a fast and effective response in case of the responsiveness event. So for now, we will just be focused on redundancy, because we can really assess redundancy by using an hydraulic model, and we can do that by analyzing the following situation. So we can isolate a pipe in the network, we can run the simulation, and we can look at the number of properties what we have that are customer point inside WS Pro with a pressure below a certain threshold for a certain period of time. Then we can repeat this type of analysis for the next pipe and so on for all the pipe in the network. And we might want to analyze the scenario where the pipe isolation can last just for a couple of hours or maybe for a day, or the scenario where the pipe burst occurs at peak time or during night hours. So we have a client in the UK that is doing this kind of analysis quite regularly, which are Bristol Water. They really put a lot of effort in critical link analysis, so I think that they would be a very good reference to talk about this type of operation. What is worth to mention now is that this kind of analysis need to be performed using an hydraulic model and not by simply looking at GIS information. So just to make an example, here we have this town at the top of the screen here that is fed by 3 main. One of the 3 main has been isolated to perform this critical link analysis. And if we were counting the number of property affected just based on GIS information, we will have this property affected. But when we actually run the simulation, we can see that the whole town here has low pressure issues, and these degrees of knowledge can only come from running an hydraulic simulation. So you really need an hydraulic model to assess this criticality. So we can imagine that performing this type of analysis could be extremely time consuming in terms of time required to define all the different scenarios, but at the same time in terms of time that we need to perform all the different simulations. Thinking about network with 10,000 pipes, we will need to run something like 10,000 simulations, so it's very time-consuming task. Within WS Pro, we have a specific type of simulation that is called critical link analysis that we can use just to perform this type of simulation. So we will need at first to specify a selection of pipe that we need to assess. Here we need to specify the criteria that we want to maintain, so a minimum pressure for a certain duration, specify the outage period, so do we want to isolate the pipe for the entire simulation or just at peak time or for a specific period of the day. And you can see here at the bottom that we have the ability to retain some service level only, which means that at the end of the simulation, at the end of all the simulation, each pipe will be associated with a number, which will basically define the number of property that will be affected if we are going to isolate that pipe. So unuseful information. In addition to that, with WS Pro now, we have the ability to run all the simulation in parallel, and that means a huge time saving in terms of simulation time. And I'm just going to show you this later on when I will move into the software, the performance of the software working on a workgroup environment. So as I was saying, this is quite an important information because really define the redundancy of the pipe. So when we talk about resilience, this is an important type of information, but a lot of people also do risk analysis on their system, and as you know, risk can be defined by the product of likelihood of failure and consequence of failure. So likelihood of failure can be defined by looking at the pipe burst history or age of the pipe, material of the pipe, but when we talk about consequence of failure, really the number of property affected by an isolation is a very important information to know. So I'm moving now to the third point, and again I will cover this later on in the software as well. The third theme is customer expectation, and the approach here is based on common performance commitment. The idea is essentially that the individual water utility make bespoke performance commitment to their customer, which basically qualify the quality of the service that they will deliver for them over the next 5-year cycle. However, there are 14 common performance commitments that are defined by OFWAT in PR19, which cover the issue that matter the most to all the customer. When we talk about water system, we can cut down this common performance commitment just to 9 that are highlighted in yellow here. So in order to be compliant with these 9 common performance commitments, what we really need is to move towards an integrated solution where you can actually share data between your hydraulic model, your asset management solution, and your SCADA intelligence, so your SCADA system. The heart of the InfoWorks solution is the workgroup database, which is a new type of database that we have implemented inside WS Pro. The workgroup database is really inside the Infinity system as well, which is our real-time data analytics tool, and is inside IWS Pro for real-time modeling and Model 360 for sharing results from an hydraulic model with a web dashboard. The workgroup data server database is also inside InfoNet, which is our asset management platform, and in InfoNet Mobile, which is our work order management solution and data collection solution for operators that are out on the field. So you can really see from this slide that the workgroup database is the heart of the InfoWorks solution. And on a certain extent, if we want to continue with this analogy, we can think at the hydraulic engine that we have inside WS Pro as the brain of the InfoWorks integrated solution. So just to mention some example of working on an integrated solution, we could use InfoNet as a model building tool based on GIS data, but as well based on asset management information like survey, asset condition, and so on. We can then move our model inside WS Pro and run the simulation to assess flashing schedule, for example, define the flashing sequence and the impact on the entire system based on hydraulic modeling result. Once we have defined this, we can then send this information back to our asset management tool, which we can then use as a work order management solution to drive the team out, the crew out on the field. But the same model can also be linked to SCADA data to perform real-time modeling, which means comparing the information that I have from my hydraulic model with what is really happening out on the field, and see if there are discrepancies which could potentially highlight a network fault in the real system. So it's a very useful information. And if that happens, we can actually send all the incident back to our asset management solution, and with InfoNet Mobile manage the work order as well. Or perhaps we simply want to look at SCADA data to perform real-time data analytics. So looking at the minimum 90 flow, see if it has increased over the last days, and if this happens, we can actually use our hydraulic model to locate the location of the leakage, and again send that information to InfoNet. So you can see that the benefit of working on an integrated solution is really a value for the entire company, because you can share information from different teams within the same water utility in a much easier and consistent way. So I'm just now going to switch to the software, but before doing that I want to highlight what for me are the key product feature and benefit of working with InfoWorks WS Pro. So we already mentioned the fact of working on a workgroup product with distributed simulation capability, so I won't spend a lot of time on that. WS Pro offers corporate integration with the ability now to run scripted automation processes. Using Ruby script, we can automate some stuff that we do manually inside the software. We can update our model from our asset database, InfoNet for example. We can update from GIS system using Esri or MapXtreme, and we can update our model from telemetry as well. It does offer full integration with IWI Pro and Model 360 for live modeling and sharing the result on a web dashboard. But also we have several types of run available inside WS Pro that we can use for all the different purposes. So what I'm going to focus now over the course of the presentation is just 4 simulation. Critical link analysis is the first. Then I will talk about the generalized multirun, which is a new type of simulation that we have implemented inside WS Pro, which wasn't inside WS in the past. So hopefully you will find it quite interesting. And then I will talk about the leakage locator run and the flashing scheduler. So all the simulation that I mentioned over the course of the presentation. Before really moving into the software, I'm just now going to ask you the second question, which is actually quite interesting because it's define what is your number one challenge when you build an hydraulic model, independently from the software that you're working with. Is it getting telemetry data for verification? You don't trust your data. You have different data coming from different solutions, from different points, from different source, lack of proper tool, or if you don't have any problem at all. Okay, so just now going to share the results so that I think that it will be, I hope that will be quite interesting for you. So quite a few of you don't trust the data, but also well, a good percentage struggle to get information from telemetry. So I will keep this in mind as I move into the software and try to cover this, especially the second point, getting telemetry information when I will moving into the software. So I hope you can still see my screen. I'm now going to quit PowerPoint and switch into InfoWorks WS Pro. Very good. So this is the user interface for InfoWorks WS Pro. I'm currently running version 3.0, which will be released, I think, next week. It contains some new stuff that I will eventually share if I have some time. But really, everything starts from the Tree Explorer, where we have the definition of the master database that we are working with, and within the same master database, we can have different model group for different models that we have to deal with. Each model group is then organized with different object type so that you can basically keep everything organized on while you are working within the same master database. So I'm going to start just by talking about the critical link analysis. And then as you can see from the run dialog, critical link analysis is one of the run type that is available inside WS Pro. When you look at the option, you can basically see this is what I was showing before in PowerPoint. We have a selection of pipes that we want to assess the criticality, specify the constraints, and I'm here saving just the summary report only. So when I have this schedule run button actually, which I can choose to run the simulation on this computer or on any of the machines that are connected to my pool of dedicated machine to perform the simulation, so the remote agent, or I can actually give the simulation, the workload to the coordinator, and which will then split the job. So if I press run the simulation, the software will tell me you're just about to run 51 simulation. This operation might take a long time, but actually because I'm running on a workgroup environment, it shouldn't take that long. So from the job view, you can actually see what are the machines that are performing the simulation. So you can see that some simulation have been performed on my computer, some simulation are performed on dedicated agent, and we can run all these simulation in parallel. So InfoWorks WS Pro is a multi-core application, so you can run multiple simulation on your machine, but you can also outsource simulation and use dedicated agent to perform the simulation. So just to very quickly show the result of the critical link analysis, I actually ran the critical link analysis before on the entire system, and what I created a team here which basically show the criticality of pipes based on customer point that are affected should we have to isolate the specific pipe. So I guess that all of you should be familiar with the critical link analysis because this is something that was in the software before. So I'm just now moving on and talking about this new type of run that we have implemented inside InfoWorks WS Pro, which is the generalized multi-run. If you look at the run dialog, we have the option here to choose to run a generalized multi-run. And you can actually see that we have to provide this generalized multi-run configuration object that we can define within the software. So the generalized multi-run is essentially the ability to use a wizard to define different modeling scenarios. And then we can run all these different modeling scenarios in parallel and get the information that we want. This example here is to assess the burst. So should a burst happen on my system, what is the impact on the entire system in terms of customer affected? Still again talking about resilience of the system. So I'm going now to show you how I actually define this generalized multi-run configuration object. First of all, we have a selection of nodes that I can just bring into my geoplan, and you can see that this selection basically select all the nodes that have a demand into my system. And I bring this selection on the first part of the wizard. Then we can choose what control we want to change. So we want to add an additional flow. So we choose to change the node control, and we are going to add an exceptional flow for the entire simulation or just for part of the simulation. I already performed this operation because then you can actually press this add button here, and you will see all the different scenarios appearing here. So what you can see from this grid view here is basically a summary of what the software is going to perform. In this simulation, we are going to add the additional demand, which is 10 liters per second for the entire simulation on this specific node in my network. Then I will perform another simulation putting the same additional flow because I automatically created it on this node, and so on. So if you look down here, we have 793 points where we are adding this additional 10 liters per second. If you think about it, it is useful to have the ability to run all the simulation together, but then you will actually have to look at the result. And if you have to assess the result looking at 793 simulation, it will be extremely time consuming. So within the wizard, we have the ability to specify the specific information that we are looking after. So from here, I don't want to save really the time value result. I just want to keep the summary report only. And the way that the summary report is generated is defined on the Analysis tab. So here I have the ability to choose some of the default result from an hydraulic simulation, but what I'm doing here is really using a query that I have defined in the software to select a specific result. Now, if I open and drag the query into my network, this is the base simulation. I don't have any additional flow. In my base simulation, I have 38 customer points which are affected by a specific condition. And when you look at the syntax of the query, you can see that we are selecting from the customer point where the simulation pressure, the minimum simulation pressure over the course of the simulation is less than 5 meters. So on my base run, I have 38 customer points that have pressure below 5 meters. So once I have defined this object, I can save and run my generalized multi-run, which I'm not going to do now because it's 793 simulation. I might do that at the end of the webinar, just while Stuart will be asking the question. For now, I will keep going with the result. As you can see, we can open the result from a GMR as a summary report because I choose to store only the summary report. And the information that I got here is quite interesting, I think, because when I add this additional 10 liters per second to this node, I will have 971 customer points affected by low pressure. When the same flow, additional flow is put on this node, I will only have 159, and here 89, here 38. So it's unuseful information and is slightly different from the critical link analysis. But we also have the ability now to open the summary in the geoplan, so we can create a theme to basically display the result of the generalized multi-run on this specific example. So if you look at the thematic key here, I basically have a contour, and in this red area here, in the red zone here, when should a burst occur in this zone, I will have 978 property affected. I have a yellow area here, which means that it will be between these two values, and the more I got away from this part of the network, the more the system will actually behave better. So as you can see, in the critical link analysis, we were isolating a pipe and see the impact. In this generalized multi-run, in this specific example of a generalized multi-run, we are adding an additional flow, simulating a pipe burst, a potential pipe burst on our system. And it is relevant because we know the number of property affected. So we know that we need to pay attention not to have a pipe burst in this zone. Otherwise, we will end up with a lot of customer that will run out of water. So just to very quickly give you another example of a generalized multirun, which is actually similar to what I did before assessing the pipe burst. Here I am really assessing the hydrant. Should that hydrant fail and remain completely open for the entire simulation, what is the impact in terms, again, of customer that are affected? So these are the hydrant that I have on my network. I'm creating here an hydrant profile, which basically means that the hydrant will be completely open for the entire simulation. And again, for the result, I want to keep the result, the summary report, and I'm just about to use this query, which look at this number of property affected. So when you load the result on the GeoPlan, so again, open as a summary in the GeoPlan. Probably we want to bring the hydrant on top, so we can just press apply, and so we have a clear view. We can see that this hydrant is the most important hydrant that we have on this network, because should this hydrant remain open for a day, we will have quite a huge number of people affected by low pressure. And again, these hydrants are still important, but you can see that the channel one are just affecting between 43 and 400, a little bit less than 400 people. So the generalized multirun again is very wide in terms of what you can do with the generalized multirun. So if you have any interesting idea that you would like to share with us, potentially to improve the wizard for any potential use of the GMR, please send an email to us, and we are happy to hear your feedback on this. So moving on now, on the PowerPoint presentation, I mentioned the ability to run a leakage locator run to basically identify where the leakage are on our system. I just want to start by saying that this type of simulation really relies on the quality of your model, on the amount of sensor that you have out on the field, and also on the leakage amount. So we will need the right combination of these three information in order to really locate the leakage using an hydraulic model. But in this specific example, you can see that I have a label here which show the pressure simulated and from telemetry on this specific node in the system, and here you can actually see the graph. So you can see that the behavior is actually very good. We have, it's probably ideal, I would say, but we have the same label here, and you can see that the difference between simulated and observed pressure is consistently different. And you can see that there is a drop in the pressure observed from telemetry here, which is essentially a pipe burst that occurred in the system. So within WS Pro, we have the ability to run a leakage locator run, which again is another type of simulation that we can run from InfoWorks WS Pro, where we have to provide some information. First of all is the leakage rate, or the pipe burst rate, the volume of water that is going out from the pipe, and we can really easily get this information just by looking at our telemetry system. We can then specify a selection of nodes where we want to apply this additional leakage rate. The software will run as many simulations as the node in the simulation, putting the additional leakage on each specific of the node, run the simulation, and compare modeling result with telemetry information. And of course, as you can imagine, the closer would be the value that has been simulated with what has been observed, the closer we will be to the specific point in the system where the leakage is. So you can see here the result of this critical link analysis shown as a contour again, and you can see here that the pipe burst on my system actually occurred here. So I managed to really cut down into a small number of pipe, the exact location of the leakage. But again, this is an ideal condition where the model is very good calibrated. The last presentation, the last simulation that I will cover as part of this webinar, I will then move to something different, is the flashing scheduler, which is a type of simulation that we have inside WS Pro, which basically allows us to assess the impact of flashing sequence based on the entire system based on hydraulic modeling result. So when we do flashing to score pipe, to increase the velocity on the pipe in order to remove sediment from the pipes, we don't really care about the impact of this operation on the entire system. But because we have an hydraulic model here, we have the ability to define all the different sequence that we have on our flashing schedule, and to see the impact on a wide extent. So you can see here that I have defined sequence 1, where I'm actually going to flash this pipe that I can trace, and I can zoom into the selection. So we are starting by flashing these pipes. I have this flashing point, and I actually close this pipe. So we have the ability actually to show closed and open pipes and valves inside WS Pro. This is something that is coming out with the version 3. So if you're using 2.5, this won't be available, but again, 3 is going to be released very soon. We have basically implemented some factory default theme that you can load inside the software. Now that we have this factory default theme on the visual page of the property and themes dialog, we have some of the themes that are most used by the people that use the software, like flow direction, display where my live data symbols are, pipe closed, valve and control status. So as soon as I press this, you can see that I can see the direction of the flow, but as well the pipe that have been closed for the specific operation. So once we have defined this information here, we can run the simulation and see that the velocity on this pipe is 1.51 meter per second. In the criteria for the flashing schedule, we have specified a minimum required velocity of 1.5 meter per second. So we are just a little bit above this specific constraint. We are actually in this sequence 2 that we can trace and again find the selection. We are a little bit below, but again we are very close, so we are probably happy with that. And again, because I'm running the simulation, I can easily look at all the modeling results as well. So you can see here that I started by having a high velocity. That's because I was flashing the pipe that was downstream. But here, this is my velocity, and I can actually auto-label to see what the exact velocity is at the specific point in time. So once you have defined all the sequence, you then want to share, of course, the result of your analysis. So within WS Pro, we have the ability to create a workbook, which basically summarizes the action that we have been studying before. So for example, in this action, we are going to close these paths. We are going to, this path is actually staying closed from the previous action. We need to open this path, and we have the calculated flow, the minimum flashing time, and all this kind of information that are useful for the guy that actually had to perform the flow. So when I was talking about leakage locator, I just mentioned the ability to compare with telemetry information. And because you said that sometimes you struggle to get telemetry information on your hydraulic model, I just want to spend a few words about this live data configuration object. So within WS Pro, we have the ability to connect directly to your telemetry database. And we can connect to different types of databases. So we can connect to SQL Server, Oracle, which are the ones that are widely used. But we can also connect to more specific type of database. So Historian, ClearSCADA, PI. So on the logon page, we will basically need to specify the connection with this database. Then we need to define all the feeds, which are the streams that we are basically observing from our telemetry database. The third point would be basically to define the live data point. So cross-match the telemetry point on our telemetry system with the object ID that we have inside our hydraulic model. And once we have done this, and we have to calibrate the simulation, when I just open the standard run that I have here, Newtown jail, for example, we have the ability to right-click and select the live data point that we have on our system. So you can see, for example, that I have this reservoir is actually a live data point, so I can plot the depth, but I can also now bring my live data configuration object that I have defined, and I can press this apply live data button to see side by side on the same graph the depth that has been simulated by the software with the depth that has been retrieved from our telemetry database. Now, InfoWorks WS Pro provide a lot of results, but really when it might be important for you in your organization to share the results coming from InfoWorks WS Pro with a wider audience, maybe with people that are not modeler. So we have just released a new web dashboard for InfoWorks WS Pro, but it really works with the workgroup database, so you can use it with IW Live, with InfoWorks ICM if you are on the wastewater side, really everything that uses the workgroup database. And this web dashboard is basically allowing us to share modeling results with a wider audience. So you can see that it's divided in two sections, live run and engineering run. Engineering run are just the simulation coming from WS Pro. You can see that the more that I zoom into my network, the more I start to look at the point, at the customer point, and I can right-click from this web dashboard to look at actually what is the pressure for this specific customer point that has been simulated. This operation might take some time for the first time because it actually is looking at all the simulation results. But you can see here that I have the simulated pressure from the software. Because I see that we still have some time, I might want to spend a few words about the model build tool that we have inside WS Pro. But before doing that, really, I'm really interested about this question that I'm going to ask you. So, do you really trust your model? The answer can be they are very well calibrated, 90% of the cases. Between 50 and 60%, I trust my model, 10, 20 and 50, or I hope not, this is not the case, no, I don't trust my model at all. I really hope that this last option will be very, not a lot of people are going to choose this option. So I'm going to close now and to share the results so that you can, it's quite good, I would say. The vast majority of you have a quite good between 20 and 50, but at the same time between 50 and 60%. So I would say that is a quite good answer. Before really heading over to the last part of the webinar where I would be answering the question, just want to mention a few words about model building tool. I started by saying that we generally bring GIS data inside our model. To create a physical representation of the system. The way that we do that inside WS Pro is by using the Open Data Import Center, where we can choose the category of the object that we are going to import, the source type, which can be a shapefile, which can be map.info or a CSV file. And then we are basically to cross-match the object fields inside WS Pro with, sorry, I just realized that I didn't remove the question. Okay, I think that most of you are familiar with the Open Data Import Center, but generally here is the source, the type of object that you're going to import, the source that you're grabbing information from, object inside the InfoWorks WS database, and object inside your GIS database. And then you have the option to prompt, which means all the time we'll ask if there is a duplicate. Do you want to override? Do you want to ignore? Merge. Basically, if there is a duplicate, it will merge, so it will save only blank fields inside the WS Pro database. Overwrite means that it will overwrite all the time, or ignore. If I have a duplicate, don't do anything and leave as it is. When you build your model, a very useful tool is flag, because basically flags indicate where the data came from and how reliable you think is your data. Just to mention an example, you have two GIS sources, one is more reliable than the other. So within the database, the master database, we can define as many flags as we want to identify the specific source that we are grabbing information from, or to specify the specific user that is editing the network. So as you can see here, I have my flag, so I can enable the flag, and basically from now going forward, every time that I modify something on my model, it will be flagged, so all the people will know that I made this change. So it's a very good way to keep track of where the data come from and how reliable it is. So Lucas Arena is not very reliable, so that's a bad flag. When we have to build our model, we then need to define the control. So if you look at this specific valve that we have in the system, we have just a few tabs in the system, but we can grab the control to basically define how the valve is behaved over the course of the simulation. So you can see that this is a throttle valve, is 11.3% open. We have the ability to write UPC script, basically to model more different type of controls, and we can choose between different parameter, water quality, turbidity, should we run a water quality simulation. So all this kind of information stays on the control page. The last element that you need when you run the simulation is the demand diagram, which basically describes how the demand change over the course of the day. So we are looking here at the domestic category, and it comes with a 15-minute time step, but really we can define, we can use different time steps. So it's quite flexible. The software will handle all this information. So here we define how the demand change as over the day, or over the week, or over the year. So we then apply this demand category to the customer point. Customer point basically represent properties. So you can see that this customer point is one property. It does have a specific consumption of 315 liters per property per day, and we are defining the pattern looking at this demand category. The final step would be basically to allocate the customer point to the closest pipe, or to the pipe that is being connected to, and that because of that we have a static demand allocation process that we can run in order to associate the customer point with the pipe and with the node. So when you actually start by looking at the run dialog, you can see that these three items, network control and demand diagram, are the three items that you need to run a simulation. Then if you want to do something more, you can define different object, different RAM type, and start to do your analysis. But this is really the basic. So I mentioned the ability to run SQL query. That's another thing that is quite powerful in the software. We can run SQL query to select specific information from the model, to select specific information from the result, but as well to modify some parameters on our hydraulic model. So that's an easy and quick, maybe not super easy, but it's a quick way to edit your network if you have to do some batch edit. So I think that this is over for the presentation that I have. Thank you very much for listening, and now just want to find out from Stuart if we got some question.
Thank you, Luca. Actually, you've had quite a large number of questions come in. We certainly won't be able to answer them all now. What we'll do is we'll go through a few now, and we'll come back directly to those that we don't have time to answer in the next few minutes.
Okay.
So the first one, by running critical link analysis and generalized multi-run, you will end up with lots of results. Is there a way to reduce the size of the results?
Okay, yeah, there is. Before actually answering to this question, I actually forgot to start the generalized multi-run, where I'm going to run 793 simulation, and then I will answer to this question. So basically choosing to rerun the simulation using the work. So it will take some time to do the initialization, but then you will see hopefully that on the job view all the simulation will run together. So to reply to this question, Stuart, within WS Pro we have introduced a new object which is called result selector. And of course when you run a lot of simulation you have to save a lot of results. But within WS Pro, we have the ability to choose to define a result selector, where we can actually choose to save the result for the specific object type, or for a selection of objects within this object type. And within this object type, just to specify the specific parameter. So an example will be node for a selection of node, and I want just to save the pressure. So that will reduce the size of the result, but at the same time will also improve the performance of the software, because it will have to write less result back to the hard disk where you are storing all the results. The simulation has started, so you can see I have quite a few machines here that are running, and you can see all the simulation running in parallel from the GMR.
You mentioned the ability to run scripted automation processes using WS Pro Exchange. Can you explain what kind of operations you can actually automate?
Oh yeah, basically WS Pro Exchange is something new that we released a couple of months ago. So the idea is basically to let the people to run script to automatically perform specific action. So one of the most popular example is just by running the Open Data Import Center that I was showing before. People want that generally to update their model on a regular basis. So with WS Pro Exchange, we can automate that process. So we can, for example, automate. We can update our hydraulic model from our GIS system once a week. And then we can do that with Exchange. Then we have the ability to automatically start simulation. And to do comparison between what's been simulated with telemetry, and as well to export results. So in theory, we are basically providing the ability to use the hydraulic engine inside WS Pro without having to use the user interface. And for some people, this operation is very convenient.
Can you tell us the main differences between WS and WS Pro?
Yeah, okay. So basically, I guess that a lot of the people here are new to WS Pro and to its environment. We already mentioned during the presentation the idea to work on a workgroup product. We already mentioned the result selector. What else is new is basically these two buttons here that we can basically use to undo and redo specific change in the network. So if we want to go back, we can undo the change and go back to the change. We have a GIS finder, so you can use Google Maps or OpenStreetMap to search for a specific address, and then you can find that address into your model in the GeoPlan. 64-bit technology, so it's generally faster. The generalized multirun is something that we have already covered. By the way, the software just performed all the simulation. So these are the first thing that comes into my mind, but there are a few other things. The user interface generally looks pretty much the same, but it's the technology that is underneath the product that has changed. So that's the answer.
Okay. There's a second part to that question. In WS, I used to get a log file at the end of a simulation.
Yeah.
How can I get the same log file from WS Pro?
Yeah, okay. So basically in WS, you didn't have the run control. You had the log file that was showing the progress of the simulation. We can still access that specific information. So from the run, you can open the run as a log result, and this is basically exactly the same log report that we were showing in WS before. If you're using this to identify snapshot that have failed to converge, one useful task to do is basically looking at the sidebar. So you can see that if the sidebar is green, it means that there are no snapshot failure. If there is a snapshot that fails to converge, the bar will be yellow, and at the specific time when it failed to converge, it will be red. So if you have this situation, just go into the simulation, open as a log result file, and you can see what is going on here.
Can I create themes to compare results between two different simulations?
Yes. So we have 4 times. I will just try to show that. So we have the ability to. So I basically open the results for a specific run, a normal run, and I have a pressure-related demand. We can open as an alternate result for comparison. So we have the true result here from the two simulation in the GeoPlan. So if you look at the specific pipe and you look at the flow, we can graph alternate result for this specific pipe, and we can see the difference in the flow between the two different simulations. But we are here really looking at on an object by object. We have the ability inside WS Pro to create a theme to basically display the difference. And the way that we do that for the pipe, for example, is to basically use a SQL query. We can create a new query to display flow difference, for example. And from here, we know that we are looking at the pipes, we are looking at the result from the simulation, and we want to look at the flow. So this will be the flow on the simulation number 1. We can deduct the information that I have on simulation number 2, which is the pressure-related demand run, and again the flow. So we can save this query, And in theory, we can, it's not letting me saving for some reason. Close. And then we can basically create a theme. The software will automatically look at the different value and create a theme to display the difference in the gel plan as well. So not only object by object, but I have a general view of the network. So I feel that this answer to the question. Yeah.
Okay, thank you. There are quite a few more. I do apologise, we're not going to have time now to answer those. We'll come back to you directly afterwards with responses for those. Okay, with that, I think we're just about done. I'd like to thank you all for joining us this webinar, the next generation of hydraulic modelling with InfoWorks WS Pro with our presenter, Luca Serena. I wish you all a good day and thank you very much. Take care.